So good morning, everybody. It's 10 o'clock, and I think we'll start now. I think some more people may be joining in the coming minutes, but that's okay. The introduction is usually not the most interesting part of the webinar, and this will not be an exception, I think. In any case, welcome everybody. It's very nice to see many people have joined already. This is the third webinar of the MAIA project. And the MAIA project is funded by the Commission to support ecosystem accounting in European countries, national scale. And in the MAIA project, we follow the framework of the SIA, the System of Environmental Economic Accounting, designed and developed by the UN. And in the SIA, there are 4 core accounts and 4 thematic accounts. And in the revised SIA, so there are some changes in the current revision. We have the same core accounts, so extent, condition, services, and assets. But we have 4 slightly different thematic accounts: biodiversity, carbon, oceans, and urban ecosystems. And the idea of the MAIA project is to offer one webinar related to each of these accounts to people interested in the EU and also outside of the EU to learn a bit more about SIA ecosystem accounting and the underlying methodologies. Now, the first MAIA webinar was it was an introduction to SIA ecosystem accounting. The second webinar dealt with condition accounting. This is the third one about ecosystem services modeling and accounting. And the next one will be about extent accounting. And for each of these webinars, there's a recording. And so please be aware. It's also you're also informed on that in the invitation that also your questions will be recorded, and we'll post the recording on the website of the MAIA project. But as mentioned, this webinar is about ecosystem services modeling and accounting, and it is organized by Professor Benjamin Burkhardt from Germany, and he invited also Rob Dunford to co-present and to present also in this webinar. So I'm sure that we will all learn a great new deal about modeling ecosystem services, and I think I will give the floor now to Benjamin, and really look forward to this webinar.
Yes, thanks a lot, Lars, for this introduction, and thanks for inviting us here to give this webinar, of course. I'm glad to see so many people coming in here and have registered for this webinar. And of course, before we start, a happy new year to everyone. If we haven't met yet, this is still a new year. And we are very glad to tell you about spatial modeling of ecosystem services to be used in ecosystem accounting. And the idea is that first I give some rough overview what spatial modeling and spatial aspects of ecosystem services supply and use are. And then Rob will continue with the presentation of the most common ecosystem services spatial models. Then we have the chance for questions and answers. I guess you all saw the program. Then we'll have a 10 minutes break, and then we will continue with some 2 different methods that can support you to find the right method for modeling ecosystem services. And then I will give another short presentation about some tricky points of ecosystem services modeling. And then in the end, we will have another chance for discussions. And around 12 o'clock, 12:15, I think we will be finished. But before that, we hope we give you a lot of material and food for thought. Then I will start with the introduction of spatial aspects of ecosystem services supply and use. As you all are aware, and this is copied, as Lars mentioned already, we are following the SIA AAA. And some definitions and things, material I'm using is copied or taken from the draft document for global consultation, chapter 6, which is on ecosystem services accounts. You're all welcome, of course, to download these documents and to read them and to provide comments. I will provide the links also later on if you don't know it yet. So their ecosystem services are defined as the contributions of ecosystems to benefits used in economic and other human activity. And the important point for us is that all ecosystem services are treated as being supplied by ecosystems. So either individual ecosystems like forest providing air filtration, or in combination, so catchments for water regulation services or combinations of different ecosystems in landscapes. So that means that all ecosystem services are supplied and used by or in ecosystems. Therefore, all of them are spatial phenomena. So you're welcome to think about if you have an idea of any ecosystem service which is not a spatial phenomena, then please tell us and we can discuss about it. But I I'm convinced that all are related to space and to time, of course, also, and to ecosystems. Otherwise, there would not be ecosystem services. So if we then analyze then and map these ecosystem services and related patterns, this really helps us to understand ecosystem service supply and use, to identify areas that are relevant for supply and use. We can see where there are hot and cold spots of use and supply of ecosystem services, and also where there are mismatches between supply and use, where supply doesn't fit the demand, or there are unmet demand areas. So this is very relevant, of course, for spatial decision making, for planning, and for resource management. If we model and map ecosystem service supply and use, this is a very good tool and very important for ecosystem accounting, and of course also for ecosystem services-based policy and decision making. We face a lot of challenges when we are modeling ecosystem services, especially for the biophysical accounts. So what we have to provide is information about service supply and use. This information has to be spatially and temporally explicit. This information has to be robust, consistent, transparent, and logical, of course. And we have to integrate information of very different quality and quantity. This means all kinds of data, from satellite-based land cover mapping to direct measurements and monitoring in the field, counting, modeling, all kinds of different information. We have to integrate these quantification approaches to come to these ecosystem services, models, and maps in the end. And these results have to be understandable for a broader topic, for a broader audience. And this audience does not always come from the modeling domain, but it's really transdisciplinary. So these results really have to be communicated in a way that it can be understood by a very broad range of people. And of course, this information has to be policy and decision-making problem relevant. So we like to do maps, of course. Many of us are geographers, we love maps. But of course, in the end, it's always relevant for some problem or question, so the maps really can be used in the end. So from ecosystem service supply, this is for all services, or almost all services, but especially for regulating services, their supply is dependent on certain factors. And this is a combination in real ecosystems, biological and human factors that should be considered there. We have lots of cases of joint production of benefits in agriculture, but also in forestry and in urban areas especially. So we really have to consider also the human inputs in the supply. When we look at use, we also have to describe these factors that are involved in supply. But it's very relevant to describe how and where people and economic units are engaged with the ecosystem, and where and how they use and when they use these ecosystem services. So this is where the spatial aspects come in the supply, but of course also in the use. And in many cases, not in all cases, but in many cases, these relevant factors are concerning the use is the number of people which live in proximity to the ecosystem type that supplies the service, or that are connected in other ways to the service, so in order they can use this supply there. Of course, we're dealing with spatial scales. Different spatial scales to supply and use can take place on the local, regional, national, continental, or global scale. So this is relevant to be considered. We'll come with some examples later on. But also temporal scales are very relevant. So some services are supplied rather in rather short periods or moments. Others are supplied and used on hourly, daily base, or monthly, up to centuries. So this is a combination of spatial and temporal scales have to be considered in our models to make them a bit more dynamic also, but this makes the modeling, of course, more tricky. And we have to select the appropriate scales when modeling different ecosystem services. And this is different for each service, and whether we look at supply or use or both, because also the ecological processes that are behind the supply of this service take place at different spatial and temporal scales, and also the services resulting on them are supplied and used at different spaces and times. So different quantification approaches are needed for the different spatial and temporal units, and also the results are different at spatial and temporal scales. And of course, if we want to bring them together for accounting and for decision-making processes, these results from the different scales have to be harmonized somehow to make them comparable also. So this is another very big challenge. And this harmonization usually introduces uncertainties. If you have to do some generalization across space and time, this always involves uncertainties, which need to be communicated appropriately if you want to make your results useful. Oops, pardon. We talk about ecosystem services, stocks and flows. So services are realized when human benefits from the services. So that means when, so in a time scale and also where, in a spatial scale, supply meets the use and ecosystem services flow, so to say. And these flows can again be very dynamic over space and time, and are very difficult to capture by our models. So quite often we can see that stocks are mapped and quantified because this is easier. It's a bit less dynamic. Like if you look at the trees in a forest, this is easier to map than to really quantify how much forest is harvested there, when and in which places. So ecosystem services are supplied in service providing areas. So sometimes you also will find the term SPU, which is service providing units, which is basically the same. Or in accounting, you find the term ecosystem assets. I will provide a definition about assets in a minute, but it's the same, but not exactly the same, but it's very important to be aware about it. So we talk in modeling about service providing areas and service benefiting areas. These are the areas where people benefit from them, so where they are used. And these areas can be connected or linked to each other by service connecting areas. If we talk about ecosystem assets, this is again copied from the newest SEA documents. They are contiguous spaces of a specific ecosystem type, for instance, a forest or a wetland or a lake or an urban area. And each asset supplies a set or a bundle of ecosystem services. This is a bit different from the service providing area. There we can look only at one service, but the asset is defined that it supplies several services. And these services are recorded as flows between these assets and economic units. And economic units, they include different institutional types, which are included in the national accounts already, and businesses, governments, and households, so more private use. And if it's relevant for the measurement purpose and the description of the respective service, so it may be useful to highlight particular ecological characteristics of this ecosystem, like the condition of the ecosystem from the condition accounts that are relevant for the ecosystem service supply. This fits quite well to what we are also doing in our modeling approaches, just that we talk more about service providing areas and less about assets. So this is a quite well-known figure from our colleagues from Dresden, and it's very relevant for thinking about spatial relationships of ecosystem services, supply and use, where they put these service providing areas and service benefiting areas in relation. So this can take place, like in case A, either in situ in the same place. For instance, imagine you are at a lake and you are drinking the water directly from the lake. Then your service providing area would be the same as the service benefiting area. But this takes place, of course, also on larger scales. It can take place omnidirectional. For instance, pollination is a classical case here. You have a suitable pollinator habitat, and then the pollinators fly in all directions, and there are plants that get pollinated, so they benefit from these services. You have other cases like directional flow with slope dependence, like in case C, for instance, flood protection from an upstream river catchment benefiting an area which is more downstream, or you have directional flows. If you, for instance, now on the left side of the service providing area would you have some kind of barrier where the service cannot be transported, then this is flowing only in one direction via a service connecting area. So this is quite interesting to see and to think about how the different services can be fit into this system and how they behave. And if you think about or look at different ecosystem services, you can see some typical patterns. Regulating services, in many cases, they have to be physically connected, this service providing and service benefiting area. For instance, think about flood regulation. This really has to take place in the same watershed, basically. It doesn't help us in Europe if there is some flood protection provided somewhere in North America. So this really has to be connected. The same with pollination pollinators fly, but they cannot really be transported. It's different in most cases for provisioning services. They can be traded and transported. So these providing areas and benefiting areas are quite often spatially decoupled, and the service connecting area can be quite large, reaching up to global scale by transportation. Of course, there are some goods that cannot be transported so easily, but typical pattern is that this can be a bit decoupled spatially. And for the cultural services, this is usually more complex, the relationships between service provision and service benefits, due to the intangible and cognitive nature of many cultural ecosystem services benefits. So this is worth to think about: where do you consume the service, use the service, where is it supplied, and how is this connected? So there's quite hard to define these clear patterns and areas. I put some examples here for different ecosystem services. There are spatial scales, and then some examples for the service providing and benefiting and connecting areas. Like if you think about a single tree for local timber provision, could be a household who's benefiting from it, and then the connecting area with the transport path. Maybe some people just cutting a tree in a forest and then bringing it to their home. So this would be the flow of this ecosystem service. If you think about timber on a bit larger scale, of course, a whole village could benefit from it, from the whole forest, and again, this would be transported. This is, of course, rather simple examples. Gets a bit more complex when you think about flood protection on a regional scale. It would be provided in a whole watershed. A village could profit from it, and then the connecting area would be the water flow paths, or rather the paths where the water is not flowing, because we talk about flood protection. Pollination, I talked already a little bit about. So the connecting area would be the flight ranges of the pollinators. Air filtration on the local or regional scales provided by trees could benefit a village or a city, and the connection area would be the paths of the clean air flowing. And then for landscape aesthetics, as I mentioned, this is a bit more tricky. The providing area could be, for instance, a mountain, and you benefit from it from your viewpoint where you look at these nice mountains. And then the connecting area could be the view shed of the whole area where you are able to see these mountains and nothing comes into your view. But this is, of course, for the cultural services, I find this a bit more tricky, but in general, it's possible to look at this from the different services and see where they actually are provided and how the services are eventually flowing. So there are lots of methods to map and assess ecosystem service supply and use, and Rob will give you an overview of the most common models in a minute. So a broad range is available, and this is, of course, not, this hasn't been fallen from the sky or has been invented by the ecosystem services research, but there we really can harness long-term experience from different scientific disciplines and use them for ecosystem services science. And usually if we want to assess many different services, you have to use and combine different approaches and then really harness the strengths of each method, or see what's there also based on the data and resources you have. And in the second part of this webinar, we will provide you two tools and databases will be demonstrated, how you can find the right method for your purpose. And these methods really range from rather simple methods, what we call in this tiered approach, tier 1, for instance, use a land cover as a proxy for ecosystem service supply and use, or use value transfer method to quantify your services. Then it continues with more complex indicator-based approaches that we call this tier 2, or this tier 3, rather complex process model-based approaches. This doesn't mean that tier 1 has lower quality than tier 3, so it really depends on the purpose on your study and also on the ecosystem service and the system you look at. But it's very good to know that there are so many methods around that you can use and can start your quantification, modeling, and accounting exercise by this. So this ecosystem service, spatial ecosystem service models, they are definitely applicable for ecosystem service supply and use assessments. This is also what our webinar is about, but they can of course also be used, spatial models, for extent accounting, for condition accounting. There are many models on ecosystem condition, also for the thematic accounts. A bit less maybe for the monetary accounts. Some models also that Rob will present, they have economic monetary value outputs, but we are talking here about biophysical accounts, so we look less at this usually. And with this, I will finish and hand over to Rob. Thanks for your attention for this moment. I will come back later, of course, with the other presentations. But for now, I think this would continue with Rob with the modeling, and we will have chance for questions after Rob's presentation. Thanks a lot for listening, and yeah, please, Rob.
My name's Rob Dunford-Brown. I work at the Centre of UK Centre for Ecology and Hydrology in the UK, and I worked on a project called Openness, which was an EU project which looked into ecosystem services methods in practice. So what I'm going to do is pretty much share my experiences from that with you, and this presentation is an overview of the sort of a high-level approach in terms of the models that are available for looking at ecosystem services. So let's just start with what is a model in an ecosystem service context? All models are kind of simplified representations of reality. So these are models that are simplified representations of the environment. They are different from mapping approaches in that they are not forcibly spatial, though many of them are. They focus particularly on the interactions between different components of society and the environment, and kind of the natural world and ecosystem service provision. And they're exploratory, so they're designed to be played with to look at different scenarios or internal model dynamics. So you can change a setting somewhere and you can see what the impact of that are. In terms of types of model, there's a range of different types of model that could help you in different ways. So the conceptual models, for example, here, the water cycle, as we understand it, drawn out as a diagram of flows between different sectors of an environment, is a model because it simplifies reality and it helps us to understand how things work. And that can be used as a starting point for the development of a more complicated model to understand the relationships between things. You can see how things get passed between stores and flows between different things. Statistical models are used when you have a situation where you've got lots of data and you think there's a relationship between things, and you want to see what comes out from the data. So you've got lots of records of water quality and you understand that fish populations are declining and you want to see a relationship, if there's a relationship between your water quality and your fish populations. Problems with regards to, you know, correlation not being causation, but they would give you an idea for the sort of things that are going on. Deterministic models, you know, x equals y squared is a simple deterministic model. If you understand the relationships between different components, you can set out a model that takes a set form and allows you to project into the future. Obviously, it'll be more complicated than x equals y squared, but that sort of deterministic model would be. Probabilistic models on the left-hand side recognize that it's not a matter of just a single input value necessarily, and that maybe to deal with errors or to deal with your uncertainty of the environment, you want to take a probability distribution as your input to something. And things like, you may have heard of Monte Carlo approaches, which basically sort of sample across a wide range of input parameters to get a kind of an overall swathe of what is more or less likely. So your outputs aren't a single number either, they're a probability or a chance or a distribution. And then there's rule-based models. So if you think of going back to kind of early biology, if you've got a you know, classification tree, does it have 6 legs? If so, go this way. Does it have, you know, whatever, to help you classify things. So you can get rule-based models that are set out. It's often used in remote sensing too, in terms of, you know, if the amount of reflectance is above this much in this color, it might be a tree. If it's not, then go that way. So they're a way of understanding the environment or simplifying it that can help you to sort of classify things down. And then the bottom one here I've got is integrated modeling systems. And I'll talk to these about these a bit more later, but these are joined up models. So individual models joined up with each other to cover a range of different sectors of the environment. So I don't know, an agricultural model joined up with a forest model, joined up with a water model, to give you an integrated view of how those things would work together, so that you don't have situations where a bit of land might be really well used for carbon storage, but it might also be really well used for food provision, and it can't do both. So integrated modelling systems are designed to deal with the interactions between things and across sectors. As a broad overview of the different suites of tools that are available, I'll go in more detail into some specifics in a minute. So how can models help us to better understand ecosystem services? Well, they can model ecosystem services directly. So you can have ecosystem service models. I've got an example here of a pollution removal model that uses the amount of trees in an area and the deposition from other things and works out the amount of pollutant removed. It could be a model of a natural environmental parameter directly. So there are tree growth models that tell us how much a tree grows. So it doesn't give you the ecosystem service itself, which, for example, carbon storage, but it does tell you how much, how high and wide a tree might be, from which you can then calculate ecosystem services. And then again, there's the integrated models, which deliberately deal with the interactions between different sectors. So in this presentation, I'm just going to give some examples. They are examples. There are many, many other options out there. So Benjamin talked a bit about this. This is the simple end of models, so matrix-based approaches. It's somewhere between modelling and mapping, and it can be very, very simple and made more complicated by including additional data sets if you wanted to. But at the very most simple, you basically take a value for ecosystem service provision. You can't see this one, it's quite tiny, but across the top, you've got a range of different ecosystem services, and there's a good number there. And down the left-hand side, you've got a range of different habitats. And basically, you've got a link between the two using a scoring system of some kind that you can then map out, show kind of what areas are higher and lower in terms of ecosystem service provision. The advantages of this are it's quick, it's transparent. You may not agree with the numbers, but you know what they are. It's easy to understand and communicate, and you can do it with stakeholders, so you can help them to develop the numbers in a way that reflects their understanding of the environment. The disadvantage is it's open to a massive critique of oversimplification and subjectivity. It doesn't necessarily include time in there. But the point I'm making is that modelling can be simple. The important bit is that it's transparent and that people understand the implications of any assumptions that they make. There are out there existing ecosystem service modelling frameworks. People may have heard of INVEST, the integrated valuation of ecosystem services and trade-offs. This is an existing modelling tool with a suite of 18 ecosystem services. It's a transferable approach that's freely available, it's open source, it's relatively well recognised now, it's been applied in a range of contexts across the world. You need to have GIS skills to use it. There's a reasonable amount of work in terms of collecting and curating the data that goes into it, and it doesn't explicitly deal with the interactions between ecosystems services. Obviously, it's based on the same data, but it doesn't deal with how those interact, and it's weaker on cultural ecosystem services, as many modelling approaches are. But it's, in theory, it's something you could slot into and out of a case study and transfer across contexts. Another example is Estimap, which is developed by JRC. It runs within a GIS. It now uses Python code as it's getting more advanced. But it was designed to be a standardized replicable system for the EU. Interestingly, it does some of the same services as INVEST, but it also does different ones, but it uses different approaches where it does use the same service, which again is a flag to realize that even with the same ecosystem service, there are different ways of modeling it, which will lead to different results. The priority within Estimap, it focuses on regulating ecosystem services. Mostly it does air quality, soil protection, water retention, pollination, but it also does a reasonable amount with bird habitat and recreation. Within openness, we found that it could be customized to the local scale. So you could work with people to customize the approach to, I think it was in the Cairngorm, so a national park in Scotland. So it was a model that was taken for a European scale and and customized down to a more local scale by the modeler working alongside people from a case study. But there are other tools and frameworks available. I've only done 2 here due to time, but Aries, Lucy, Minds, they're all out there. There are also papers that compare the strengths and weaknesses between these. So there's a Bagstad paper that particularly looks at, I think it's Aries and Invest and another, I can't remember what, but it does a range of different tools and uses them on the same area and shows the kind of strengths and weaknesses. On integrated assessment models, again, these are deliberately designed to deal with the interactions between services, as I've said before. The disadvantage is that they take a long time to be put together, and that, so I mean, we're talking research projects. So the ClimSave IAP to the right hand side here took 3 years to put together. We're currently working on one for Wales, which has taken a year and a half, but is delivering policy relevant outputs now. There's a lot of work. People see them as black box, although you can work alongside the end users to make them more transferable and transparent rather than transferable. But the problem we've had is that if you use a single sectoral model and you're not considering those interactions between things, you'll find that the model can misrepresent the direction of change, the magnitude of change, and the spatial patterns of change. As I was saying before, like if an area of forest and is just as good for carbon storage and just as good for food provision, what actually gets allocated to that land will determine the ability you have to deliver whichever service it is you're interested in, whether it's food provision or carbon storage. And there are examples at different scales. So the ClimSave IAP is available at the EU scale, and the Image Globio is a global scale model that again combines climatic and socioeconomic scenarios to explore futures, which is another strength of the IAMs. Again, so there are also natural environment models. So these are the ones that aren't necessarily doing ecosystem services, but are giving you proxies for them or places to start with for your ecosystem service assessments. You know, there's biophysical models related to soil erosion and soil water, so SWOT and Russell are relatively common ones, but there's a whole range of others that would just give you biophysical parameters. There are species distribution models which allow you to look at the impacts of climate change on the places that are suitable for different species, which again, if you've got the biodiversity, you've got the starting point for understanding ecosystem service delivery. And again, there's a lot of land use models that provide you with a land use or provide you with an understanding of changes in land use, which you could feed into the simple approaches or anything else that uses land use. So there are ways at getting at the inputs into ecosystem services from those. I'm going to finish with, I think it's 4 slides on considerations. The first thing to think about when modelling is which ecosystem services are you thinking of modelling? Because not all of them are as easy to model as each other. And the primary advantage of the ecosystem services approach is it's adding back in those services that are missed out with traditional accounting. So you want to be making sure you're being as holistic as possible. And unfortunately, cultural services are particularly challenging for this. So there needs to be some consideration of the value added of combining models with other methods that bring in the services that are missed by my modelling approaches, which find it easier to do regulating and provisioning services. The other thing to consider when you're modelling is that values are there. So why do ecosystem services matter and how much are big questions behind the whole ecosystem services approach. And there are lots of different ways to assess value. It can be biophysical value, it could be monetary value, it could be socio-cultural value. And of course, those values depend on who you're talking about. So values differ depending on the person involved. And of course, they're time bound. So when do the values come from? Will they change once the thing that the bees are pollinating is no longer there? So these are things to bear in mind. And it's a challenge for, particularly for ecosystem service models that provide a single value when those values may be plural. And those, again, it's a particular challenge for cultural values, but not just for cultural values, because even regulating and provisioning values change depend on the environment, depend on politics and socioeconomic context. So those things need to be borne into consideration. Uncertainty, also an issue. So there are loads of different sources of uncertainty with modelling. The data that goes in, the scenario you choose, the model you've chosen to use to map out whichever ecosystem service you've chosen. And to what extent are we really addressing the holistic uncertainty, which is to what extent do the results of this model reflect the real world output it's intended to, which is very difficult to ascertain. And of course, all models are imperfect, but you can use sensitivity testing to help. Also validation, very lovely. It's great in practice, but challenging if you don't have any data to compare it with. So that can be particularly challenging, again, for the cultural stuff, but also for, we did stuff on flood prevention. Is there a flood prevention data set out there so you can to assess against? I think it was flood barriers and that kind of thing. There's not a European-wide map of flood barriers. So these things are things that need to be considered. And finally, with models, you've got to remember they're all abstractions of reality. There are many ways of assessing ecosystem services. You need to consider the context, and transparency is pretty key. And that means with an acceptance of transparency and a recognition of the assumptions you've got in there, you need to be clear about the strengths and limitations of your approach. But there are lots and lots of options out there, and there's lots of expertise out there. So there are many options in terms of where to go. And of course, you're not forced to use a single method, and you can bring in other methods to strengthen areas that particular models are weaker in. And there endeth the epistle.
Thank you very much, Rob, and thank you very much, Benjamin, as well. I think these were two very interesting presentations in which we all got a very good overview of physical ecosystem services mapping approaches. Benjamin focused especially on the very important spatial aspects of modeling ecosystem services. And Rob provided us with a very useful overview of modeling approaches and modeling frameworks. I would like to open the floor for Q&A, but I think there's two things I would like to say beforehand. The first one is that I would like to propose that we focus our discussion on the biophysical aspects of modeling ecosystem services, because ecosystem accounting has a specific approach to valuing ecosystem services. So it's relatively narrowly defined compared to other valuation approaches. And we have a specific webinar on valuing ecosystem services and valuing ecosystem assets in the MAIA Webinar series in February. I think we should leave discussions on valuation for the February webinar. Then, in terms of asking questions, what is, I think, the most feasible is that we just use the hand raising function in the WebEx tool. So please, if you have a question, you could open the participant screen on the right-hand side of your screen. If you click on participants, you'll see that participants in that box, you can raise your hand, and then I'll try to keep track of that and make sure that I hope everybody gets a chance to ask his or her question. So let's see if there's already a first question. There is no. There is a question from Cremena. Cremena, please.
Hello, everyone, and thanks for the excellent presentation so far. I have a question concerning the airflow modeling. In terms of how it shows the use area and everything in between, which can be quite a long stretch. It's very difficult airflows in order to get to the air purification and microclimate regulation services estimation. So if you can elaborate now or in later presentation on this specific type of services, it will be very helpful. Thank you.
Was the question clear, Benjamin and Rob? To me, it was a bit weak, but did you hear it?
There was a bit of an echo. Maybe if one person is talking, all the others should switch off their microphones. Otherwise, there's an echo. As I got it, it was.
Now?
If I got it right, it was about this ecosystem services flows between supply and use areas, and special examples like air filtration. To elaborate more on this, or?
Yes, exactly. It was on how to model air filtration and air purification, because there may be a long stretch between the providing and the use area.
Yeah, this is it's a fact. I mean, this is one of the ecosystem services that are very tricky to model, because this air is just flowing wherever the wind is blowing it, so to say. But what we can model from a conceptual point of view, maybe Rob has a concrete model at hand, I don't know. You could, of course, model how much air is filtrated by the different tree and plant species. What is their capacity, so to say, to filter these elements out of the air and where they are. So the supply, I think you can model quite well. And the use, you would basically need kind of meteorological models that can model where the air is going. But the tricky thing is, of course, that was discussed also a lot in this SEA revision, that how do you do this? I mean, if there is no polluted air, so to say, there's no need, no demand for this service. So first you need polluted air, then you need ecosystem types that are able to filter these pollutants out of the air, and then you have clean air which can be used again, so to say. So this is tricky because you need this, kind of factors that really trigger the service to take place. So in fact, if you would model this, you would need to model the air pollution, the cleaning of the air, the filtration, and then the use of the air. I think it's possible, but I don't think that there's one single model that can do all this at once.
No, I'd agree with that. In terms of the stuff that we're doing at UKCH, which I'm not directly involved in, you've got a series of different models. One's doing the air pollution, one's doing the removal stuff, but they tend to be relatively. Well, the problem is that you've got the air pollution modeling happens at a different scale to the scale of the issue you're dealing with. So it's you're doing your best you can with the data sets you've got, and yeah, it's not very helpful. But there are models out there that do it, and the challenge is the data and the resolutions that they work at, and join them together to get a comprehensive answer to the question at hand.
All right, thank you for these responses. I would like to go to the next question, and I forgot last time, but please, when you have a question, also mention the institute you're working for. Bruno, you're next in the line.
Okay, thanks, Lars. Okay, thanks for the good presentations. I have a question related to the selection of the models and the use on policy decisions. I've seen at least that you refer to a paper from 2013 comparing the strengths and the weakness of different modeling frameworks, which is rather old. So I was wondering, is there also some newer stuff? Because I assume the last 7 years, a lot of things have happened, especially on that part. The second is a little bit related to that, is I fully understand the concept of integrated assessment models, but are there already some examples which show what is the impact for policy decisions using the integrated assessment models? As far as I've seen, a lot of the, let's say, papers, they select a certain model and they show the output of the model, how it can be used, but this comparison is a little bit missing, especially related to the impact on taking specific decisions. Thank you.
Yeah, I think my answer is going to be a bit disappointing on both factors there. So on the first one, I haven't seen a more recent one, but I'm sure there will be. I would have to have a frantic look around, but I'm sure that other people have been looking at comparisons between services in different places, different models in different places. And for the second one, which I forgot what it was, the answer was, what was the second question again? Sorry, Bruno.
It was related to the integrated assessment model. So switching, for instance, from a single model towards an integrated model, are there some examples on what's the, let's say, the difference on the output and could influence the policy decisions?
So you're absolutely right on that last stage in terms of the influencing the policy decisions. So there was a paper that we did that looked at the comparison between single sector and multi-sector. That was a 2016 one using an integrated assessment model with and without the interactions. which is the one that demonstrated the difference in terms of the direction, magnitude, and spatial patterns. But in terms of the link through to policy, the policy use of integrated assessment models seems to be very high level in terms of kind of world scale. I don't know of many country level drivers of integrated assessment models, but they may exist. I know that we're currently developing one for Wales, where we're working alongside the Welsh Government to match things to their needs, which has been a whole world of iterating in terms of assumptions and kind of building their understanding and our understanding of them, which is a really interesting process. But in terms of, I believe there are some in Europe, but not that I know about in detail. Sorry.
What I may add, of course, on the European Union level, that's not for Rob anymore, sorry. On the European Union level, there they use this estimate a lot, of course. The GRC creating all these ecosystem services, models and maps, and they are used in their reports and also on European Union level decision making. Also called, this is quite a continental scale. And we did one exercise when we still had this Esmeralda project in the MAIA working group, this Mapping and Assessment of Ecosystem Services European Union working group. There we asked participants to ask us questions or write down questions that could be used by ecosystem services, modeling, mapping and assessment. And I think we collected something like 120 questions that were very different. Some were very general, but most of them were very specific. Like, how can we assess pollination in agriculture on a regional scale? And this is, of course, a question that we can answer. There we have the models. So this is very broad and very complex, and there are ideas, and we will present in the second half. This is a very nice transfer to the second presentations we have, which are on model selection tools. And the one is also, of course, the purpose of your study and the policy arena you refer to, which is one selection criteria to find the right models. But in general, it's tricky, and especially this integrated frameworks, of course, they really, there are so many different questions, so many scales and complexities that I am not sure whether there can be ever will be one model that can really answer all of this. We will see. Yeah.
And I don't think you'd want one model either. But again, the things with SDMAP isn't necessarily integrated in the way that I would understand integrated. So it deals with individual services separately, using the same inputs maybe, but it doesn't necessarily deal with the combined climate and socioeconomic scenarios in the kind of way that you might want if you were looking for that kind of joined up cross-sectoral thing. But my point being that I don't think many places at the political level are really using integrated assessment models in earnest at a country or sub-country scale yet, although they should, because it would be cool.
Wonderful. Thank you very much, Rob and Benjamin, for responding to these questions. I think it's just exactly on schedule for having it. So I hope you all enjoyed your coffee break, and welcome back. I'm glad to see we still have most of the participants in the room. And now let's continue with the second half of the webinar, in which there will be 3 short presentations, 2 by Benjamin, and sandwiched in the middle a short presentation by Rob also. And after that, we will have 45 more minutes for question and discussions. So Benjamin, again, the floor is yours.
So this is, as we announced already in the first part of this webinar, and welcome back. Now we will quickly present you 2 ways how to find the right model and method. Rob gave this very nice overview that all kind of models are available, but of course, if you want to do your accounting exercise or ecosystem assessment, you would like to find the right method out of this whole bundle of different methods that are around there. Now I will present something that we developed in the Esmeralda project, which was a EU coordination and support action, which was finished 2 years ago, related to the MAIA tasks in all EU member states. It had partners in all EU member states and aimed at identifying and testing, mapping and modeling, of course, methods, and to provide guidance for the application for different purposes. We created in the end this key outcome, which is the Esmeralda Mars Explorer. I don't want to do an online demonstration, but if you want, feel free to go to this website in parallel now and check there. But I'm a bit worried about this live presentations. Usually, live demonstrations, usually something goes wrong. So I will show some shots, but of course you can go online to the website and find it there. This is basically a tool that grouped together all Esmeralda outcomes in a nice website setting. And what you have, there are 7 steps of the implementation of mapping and assessment of ecosystems and the services in your study area, starting from questions that different stakeholders may have to the final implementation of ecosystem services in your area. And it has a lot to do with stakeholder networking and integration. Then we have this key part of mapping and assessment process, where we also find the tool I will present in a minute. And we have lots of case studies and how to disseminate and communicate results. So it's worth to go there and find a lot of ideas and reports and tools that were developed or are linked to the Esmeralda project. If you go to this mapping and assessment process website, you find some text, and then you find different tools there and also methods, documentation and applications there. But I will mainly refer to this MAIA Method Explorer tool that we created. So there's, again, if you click on it, you get some more explanation how it was developed, the online tool. And if you click on this button, you will come to the site where these different tools are. So there's a collection of methods and case studies. We have a collection of policy and business questions. This may refer to the questions that Bruno placed in the first part of the webinar. We have a definition of the different tiers that I presented in the beginning, tier 1, 2, 3. And we have this Esmeralda database where we put in a lot of entries about ecosystem services, studies, and their methods. And this database you can browse if you click on it. So it's operational. You can just go there and check it. And then if you click on it, you have this first menu. So on the right side, you see already a lot of different methods, not only models, but all kinds of methods that are used in ecosystem services assessments. And on the left side, you can apply lots of different filters you want to look at, depending on what you want to know. For instance, if you say you want to add a filter on different dimension, this means biophysical, social, or economic assessments. You can browse for different countries, ecosystem types, different ecosystem services classes according to sizes. You can browse for the policy domain, policy objective of the study, business objective, the scale of this assessment exercise, this means spatial scale, or the different tier that was used there. So if you now, for instance, go on the dimension and the tier applied, we could choose biophysical and tier 3, which are the models. So this is what our webinar is about, biophysical models for ecosystem services, accounting and assessment. And then you see on the right side, we defined 11 different model types. This fits quite well with what Rob presented. So conceptual models, integrated models, statistical models, spatial proxy models. So a lot of different models that are there included. You could already browse these results and read a bit more about them. If you want further to add further filters, you can, for instance, say, okay, I want to know more about pollination and seed dispersal in grasslands ecosystems on the local scale. Then you add all these filters and they will immediately be applied. And then you see on the right side, there is, for instance, spatial proxy models. These field observations, of course, are not a real model, but they may be linked to species distribution models. But if you, for instance, click then on spatial proxy models, this database will give you some short description what this method is about. And it will also link to respective studies where this model method has been used. This can either be a Esmeralda case study. When we use this, then you get a lot of description, case study card, a methods description card, or it's existing publications. Like in this case, there were 2 publications in the database about pollination and seed dispersal using models on the local scale in grasslands. And then you can, of course, click on this, for instance, then you get more description of this article, and you also get the URL. And in case you have access, your institution has access to this article, you will directly link to it and can download it and read it and have all these descriptions. So this is quite handy and quite nice to find all these different methods that we collected in the Esmeralda project. You can read more about this. This technical implementation has been documented in an article, and also this content creation in the project, how all this information was collected and eventually implemented in this database. You can read in these 2 open access publications. So this database is I find it quite impressive. It was initially filled with 883 entries until April 2018. So this is definitely quite a comprehensive collection of ecosystem services assessment studies. We are still using this database in follow-up projects. For instance, in this Move and Move On projects, which are about mapping and assessment of ecosystem services in the outermost regions and overseas countries and territories of the EU. So we added, I think, another 50 entries about methods specifically dealing with these areas. And of course, it's always, once a project has ended, you have all the nice tools and decision support systems and websites, and you always ask yourself what will be the future of them, how they will be hosted and maintained. So at the moment, this is still hosted by the Esmeralda group, but at the moment, in future, it will be transferred to the Ecosystem Services Partnership website. It will be linked to the modeling and mapping working groups of the ESP. So we really hope that we can keep this updated, not only running the software and the database environment, but really also find new entries. And they are really welcome, especially with regard to ecosystem accounting methods. So if there are specific methods related to this, we are very happy to enter it there. And there was also an idea to use this tool in the MAIA project, that we can really update this and have more information all in the future. But otherwise, it's very applicable, and you can go there and browse it and use it and find hopefully useful information there. With this, I think I'm 1 minute too early, but I was a bit longer in the first presentation. So this was the first overview, and yeah, you are welcome to go there to browse this tool and check it and to read the articles there. And I hope it's useful for you.
Thank you very much, Benjamin. Maybe a practical question that some of the participants in the webinar may have, and that is that if there's a transfer ongoing to the ESP partnership of this tool, will that mean that also the website where we can find the tool will be changed, or? You're muted, Benjamin.
I think he's saying no.
Okay.
No, yes.
If
you have the screen sharing, many menus pop up on your screen. It's very surprising. No, the layout will not be changed. We will keep it the same. It's just the link with the ESP is, we find it quite smart because there are all these working groups, and we really hope for updates of the database. But the web address will stay the same. There will just be a link from the ESP website to this tool. There will also be a link from Opera, for instance, to this tool. So we really try to integrate this more and more and have the priority of this tool safeguarded. Yeah.
All right. Thanks very much. All right. Then let's keep our questions that we may have for the discussion session later on. And Rob, please continue with your presentation, your second presentation. Thanks.
Again, this time I'm talking about a decision tree developed as an approach to help guide people through the selection process that was developed in the Openness project, which was an EU FP7 project targeting the operationalizing the concepts of natural capital and ecosystem services, so putting them into practice. And it was working alongside 27 case studies across the EU and actually in Africa, India and South America too. And each of the case studies were a real context where people had to make decisions and work out how they would, what ecosystem services tools that were available. And we had a suite of experts available on a range of tools and a range of case studies. And it was very much an iterative process between those two in terms of determining what tools would match to the case study in question. And there were a range of different contexts in terms of urban, forests and coastal and mixed rural. So a range of different contexts, a range of different tools and a range of different questions. And it ran for 5 years between until 2017. What we found is that there were obviously lots and lots of options, and within, very similar to what Benjamin was talking about, we broke down the tools within kind of three broad classes of the biophysical, monetary and socio-cultural approaches. I'm focusing most on the biophysical here because I know that's your interest. But within the biophysical approaches, there were the direct biophysical models, the ecosystem service modules, models that were agent-based, integrated assessment models, simple GIS mapping, and advanced versions of the same thing. And so we looked at those, and again, we were presenting these 2 case studies and talking to them about how they would use them. And I guess the point was that there was overlap between all of them. So here with the green ones are the biophysical ones, but these light blue ones are ones that sort of combine biophysical and sociocultural. There are ones that combine monetary and sociocultural, and these ones in the middle are kind of integrative ones that draw across lots of different ways of understanding. And again, as I was saying, it was case study driven. So we started by developing method guidelines for each of these. We had meetings and workshops working alongside the case studies to kind of iterate on these. And then after we generated the maps, well and before, we surveyed them in terms of the reasons they were having for selecting the model, so that we could put this into a decision tree that would help people in the future. And the questions that we asked them were, what were the considerations? How did the decision trees that we've made match their experiences? And of course, how would they improve the decision trees at the end of the project as a means to advise others who are coming into this fresh? Again, they're very high level. And in terms of the factors that were a consideration, there was a whole range of different things that people were thinking about. When people were thinking about biophysical models, and all the ones with X's basically means this was a primary consideration, but anything other than an X is basically this was a consideration, but maybe not the primary one. And you can see that for ones that are focused on ecosystem services methods, they're interested in integration between issues in ways that biophysical methods aren't. And this high level of expertise is needed for some along here, whereas when you get over here, the simple matrix and the advanced matrix are much less detailed. You don't need the same levels of expertise, you don't need the same levels of resources. And these are all things that you would be considering when you were deciding which method to go with. And in some ways, this table is relatively useful in itself because you can use that. And this is just, again, within the biophysical section. You can use it to kind of work out where you stand on, where your study or your issue stands on that spectrum. And if so, which of these are more or less appropriate for what you're wanting to do. But we went a step further with this. And we did the same for sociocultural and monetary methods. So we're using the same categories and the same thing, so that there's 3 different decision trees made. I'll go into more detail on the biophysical trees, but the point is that there were 3 different trees, but we flagged links between trees, and there are feedbacks within the decision tree. So it's not just a one-way approach. And they all start with a similar purpose question, which was what the stakeholders said after all of the work they've done, that having them start in different places made it confusing. So actually, if they start with a similar question and it heads off through, that made it easier to understand. And they wanted to have multimodal, they didn't want to just be yes, no, they wanted to be able to have multimodal choices. So again, we took that into consideration when making the final trees. So this is the final biophysical tree. I'm going to walk through it in a minute anyway, but you can get the idea of the overall thing. The black bits are the questions, the blue ones are the options, the greens are links to different areas, so off the tree into other things, and the red ones at the bottom are all the different kind of groups of methods that you can consider. And for each of those, there is a method fact sheet that the project produced. But even within those, there are sub ones, so that we're not saying that this is a class of models, integrated assessment models, again, so ClimSafe AAP or ImagePlay API. So there are examples within them. We don't lead you down to a set model, we lead you to an approach level. So running through the example of the biophysical tree, you start with a simple question. What is the purpose of your for biophysical assessment in your study? Is it understanding future dynamics underpinning things, or is it mapping the current state of ecosystem services? And that leads you off to the modelling options on one side, or the mapping options on the other. So if we follow mapping, it then gets, what do you want to map? Are you wanting a single ecosystem service or a holistic range of ecosystem service? Are you happy with a simpler approach, or do you need something more complicated? And then it leads you through to the different ends of the matrix, for example. But again, there are flags across here that goes, if stakeholder input is important, participatory processes could be used, and leads you through to a different tree. I'm not saying that's relevant in your cases, but the point is that there are links between the trees, and it's not just a one-way route. And also down here, actually this way, it feeds back on itself. So if you've got to the point of data, is it data that you're wanting that you can then model something from, or is it something you want to map directly? And if you're mapping it directly, these maps could be used as part of a deliberative process to fit into this or this. So it's about treating the selection of methods as an iterative, connected process, I think. So in conclusion, again, there are many methods to choose from and many ways that to select the methods. The decision tree is a very high-level approach. It's designed to stimulate an awareness of the range of tools that there are and how they connect together. It's to encourage exploration of potential methods for a given operational context. There is definitely no correct solution. And again, because it was so case study based, appropriate methods were seen to be those that could be operationalized within the context, that clearly address the study purpose within the constraints of budget, time, data and expertise, and address the range of services that were relevant to the study purpose. So it's very study based. And again, the methods can be combined to make up for advantages and disadvantages. The trees are available in the paper. So there's this Harrison et al. Paper, which has the 3 decision trees in it, plus the tables that I showed. And it makes a reasonable starting point for thinking through the system. And the fact sheets that are underlying each of those models are stored on Opla. And just for those, I've got a little slide on Opla. Opla is another repository for ecosystem service, natural capital related projects and data. But it's designed to be community-based, social media oriented, and kind of self-sustaining. It's currently got about 3,500 members. There's about 500 different products on there, tools and resources, and a range of different case studies. And you can explore it in a number of different ways. You can look through case studies and find out people who've done similar things or in similar areas. And you can look through methods and that sort of thing. And it's people can freely input their information onto it. Any methods or experiences or case studies can be added on. As I say, it's designed to be kind of a community-based platform kind of thing, sort of a Facebook for ecosystem services, if I like Facebook, which I don't. Anyway, that's that from me, I think.
Thank you very much, Rob, for that. I think that's very helpful. And it's also very good that you provided the link to the Opla website, so we can also check the repository and the decision tree that you pointed out for us. I wasn't aware of that one, so I need to check it myself as well. Again, let's keep our questions for a little bit later, and then Benjamin, maybe you can give the last presentation of the day.
So now you got an overview about the theoretical aspects of spatial biophysical modeling of services, a good overview of models and different methods, how to choose the right model and method out of this whole bunch of things that are available. Now coming back a little bit more to the conceptual level again, this is nice that we have all these methods around there, but of course it doesn't solve all our problems. And I will give some examples of challenges of spatial modeling, not to make things more complicated, but to address some issues that we are currently discussed in the SEA community, ecosystem services modeling mapping community, and maybe also get some inspiration for new ideas or solutions I would like to suggest and discuss afterwards. So the key challenge really is that ecosystems and their services and their use by humans are very, very complex. Different spatial and temporal scales, many things are involved there. So it's almost a kind of world model what we are doing here of human activities and natural processes that we ask for here. And I was showing you this, and Rob was showing you this modeling approaches, and in the end we have these nice maps of ecosystem service supply and ecosystem services use and flows. But the question is, in reality, and as we learned, all models are abstractions and simplifications of reality. Do the ecosystem services really behave like this? Do they really flow from supply areas to use areas, and how does it all work, and how can we operationalize it? So I presented these challenges in the beginning, and I will focus on these 3 first challenges, like provide and develop information about supply and use patterns, be explicit in a spatial and temporal way, and be robust, consistent, transparent, and also logical in our conceptual frameworks. So starting with one example of provisioning ecosystem services, usually it's said they are easier to map and quantify compared to other regulating services and cultural services, for instance. If you look at supply and use, we could say, for instance, food provisioning ecosystem services from agriculture. We have a field, which is, of course, the service providing area, if it's not a greenhouse or something else. From the field, it's transported to the farmer, then maybe to an agro dealer, to a refinement company or factory, then from there again to a wholesaler, then to a food company, to a food store, before it eventually ends at the consumer, which would be the service benefiting area or service benefiting unit maybe. So you see, this is quite complex. Many different people, many different units, many costs and expenses are involved. There are a lot of transportation, so it's not so easy to say. And of course, there are also return flows. So everybody has to pay or exchange something for the different goods. There's also a return flow. So this is quite complicated. It can be a bit simpler if you think about direct marketing, like the farmer selling the products on a local or regional market. Then it goes directly to the consumer. But in general, it's quite complicated. The question is, of course, where do we really locate or map or model the final ecosystem service supply and the final use? Is it really the field and the consumer? Do we always have the data about this, or what do statistical data really provide us? What kind of information? How do we really cover this complex supply and use chain in reality? This is an issue we have in modeling and mapping of these services. And of course, we are very data dependent, and quite often the solution may just be that we have to use the best available spatially explicit information and statistical data, whether they refer to consumers or to traders or to food stores, we have to see. But in general, we have to be aware that it's more complex until the field, from the field to the consumer. If you think about regulating ecosystem service global climate regulation, and this is a bit comparable to the air filtration example that Cremena asked in the first part of the webinar. So there we have a service providing area, which are the tropical rainforests, of course, also other forest areas that are contributing to global climate regulation. But the benefiting area actually is the whole world. About these atmospheric gases, of course, they flow globally. And this would be one example for this omnidirectional providing area, benefiting area relation. But where do we really map what? Where do we put our maps? And one solution, of course, would be to create maps of both and then overlay or oversect them and then really see, okay, where are the providing areas, where are the use areas, and how does the whole thing develop? This is, of course, also a strong message that the whole world is benefiting from the service, which is provided in selected areas only. Another point is, of course, the spatial and temporal explicitness of our data. Thinking about water provisioning ecosystem services, this is quite tricky if we want to use maps of the surface, like land cover maps or land use maps, but quite often the service providing areas are under the Earth's surface. So quite often this is related to groundwater and groundwater recharge, and this can of course be look quite different what we have in the ground to compare what we have as land cover on the top of the Earth, so to say. And there also the service benefiting areas may be related to point sources, to wells or water pipes or water channels. And how do we relate this to each other? Where do we really model and map what if this service is kind of really based on different service providing areas? One solution would be, of course, to assign anyway the groundwater services to the ecosystems above the ground, and assuming that groundwater recharge is related, of course, to the cover you have on the top. And the other, probably more accurate approach would be to consider groundwater as a separate ecosystem or subsoil asset, and then kind of make two models. One of the surface and where the services is used, and the other one where it's supplied, where this groundwater is. Of course, there are areas where it's not related to groundwater, the ecosystem service supply of water, but this is quite challenging anyway if you want to display this in a nice model in the end. Another example is, I mentioned already, the recreational services, the cultural services. This is a tricky one. where do we locate the supply? These are, of course, areas where there is a nice natural setting that's appreciated by people, where they like to recreate. But where's then the use and the benefits of this use? Is it in situ, the same area where the people are, where they may spend 2 weeks of summer vacation? Or is it where they live for the most time of the year? Where do they really take the benefit? Do they take it home, or is it just considered to take place in the 2 weeks where they are for their vacation period? So this is not easy to map. For this service providing and benefiting areas and flows are quite tricky to delineate and to finally put in your model. There are ideas like this estimate recreational opportunity spectrum, which relates recreation opportunities offered by the environment plus accessibility and plus where people are located. So this is one option, or uses participatory GIS approaches to model them and to map them. But the basically conceptual question remains, of course, where these benefits take place and the use. More temporal explicitness, of course, you know, nature is going in seasonal cycles, at least here in Central Europe and in most parts of the years, if you're not in the tropics. And so also the use of ecosystem services is in seasons. When do we actually model, quantify, and map ecosystem service supply and use? For some service, of course, this is easy. We just take annual values or average values at ranges and consider long-term effects. But for other services, it's more tricky. If we think about forests, which take several decades to grow, and where do you really and when do you model ecosystem service supply, for instance, then? So this is a point where we have to be very explicit which time we really apply our model and account for our ecosystem service supply and also use. The challenge to be robust, consistent, transparent, and logical comes pretty much for the regulating services. If we think about regulating, flood regulating ecosystem services, this involves 2 points. Flood regulation, of course, but also drought prevention. So the idea behind it, or the logic behind it, is the human preference of constant flow of right amount of water in the right time and place. So we don't want to have too much water. We don't want to have too few water. So how do we really quantify for this kind of human preferences, which may also be different depending on what kind of stake you have in your interest and your land use. This is very complex again. But of course, this is needed that we combine this. We can solve this if we have also maps of ecosystem service use for flood regulation, and then combine them with supply maps and really see, okay, where's supply, where's use, where's the mismatch, and how can we kind of display this in the end and hopefully find solutions. But this is a tricky one. It's similar for natural hazard protection and other, so to say, event avoidance regulating ecosystem services. Another point concerns global climate regulation, regulating ecosystem services. There, the question, what do we account for? What do we model? The stocks or the flows, or the carbon storage or the carbon sequestration, the process that is behind the carbon sequestration, so to say. So this is also an interesting discussion in SEA, what to do. If we do both, do we run into double counting, or how can we solve this, and how can we, as just our model, to really cover this? We have to consider that the actual process behind this ecosystem service global climate regulation is the removing of carbon from the atmosphere. So this is relevant. And whether we then account for the carbon that's stored or that's actively sequestered from the vegetation is maybe not so important anymore. The key thing really is that we can quantify and account how much carbon is actively removed from the atmosphere and is stored, so that we can consider this. So this is a key point. It's not carbon sequestration itself, it's global climate regulation, the removal of the carbon from the atmosphere. We also have to be consistent when talking about stocks and flows related to provisioning ecosystem services. So timber, for instance, in the forest, we have the stock, which are the trees, and the flow, which is the tree and timber harvest. So what should we account for? The supply of the stocks or the actual use and flow? I think here we can have both data, I guess. We can also model both. And it's very important to be very clear what we refer to. Is it supply, is it the flows, or is it dynamics between them? But this is not often communicated what really is behind the indicator that you want, that you are quantifying. I mentioned already the co-production of ecosystem services. That's a key issue in ecosystem service modeling because many provisioning ecosystem services are based on agriculture, livestock breeding, or aquaculture also, which is based partly on heavy inputs. One extreme example of this livestock breeding in a stable, where these poor animals may never see really daylight, or this intensive greenhouse farming where the plants are some kind of substrate. And the question is, what is the ecosystem contribution there? And what is the anthropogenic inputs that are involved in the supply? So this is a conceptual issue which needs to be addressed, at least we need to be aware of. And my recommendation would be that where possible, we should really indicate what is the human contribution to the generation of this service, and also what are external environmental effects of this production. So this is important because they usually come with a lot of externalities, a lot of negative effects, pollution, emissions, land degradation. So this should be communicated when we account for this co-produced provisioning ecosystem services. And again, cultural ecosystem services, they are not easy to model, especially talking about aesthetics. That's of course very subjective, and preferences of people are different. Some like, for instance, urban ecosystems, other like more natural areas. And how can you really quantify and account for this and even value this in the end and make them comparable? So there are some ideas to detect patterns by using participatory GIS or citizen science approaches. So you can see some trends, but anyway, this usually never covers the opinions of all people who are potential users there. This is still a quite unsolved problem. I wonder whether there can be a solution at all, or whether this always will remain on this subjective and individual level. And of course, if you think about complex goods and products, and if we want to know where all these parts come from, where there are supplies, where they are used, this is of course tricky. If we think about this classic example of a chair, which has some wooden parts, some metal parts, a lot of work involved, or where do we place the supply of this kind of good that's of course used by everybody in everyday life, but there we also really have to remember again what's the actual purpose of our assessment or accounting exercise. That is it really needed to know where each screw is coming from, how many workers were involved in this, or what do we really actually want to know? Isn't it enough to think about how much wood is involved there and where from the ecosystem it comes from? But these are questions. There are other more complex products we have to consider and think about how much into detail we really have to go, or what is our real purpose and policy question or decision-making question behind our exercise. So these were some examples. You find more in our open access textbook, which I can recommend you to read. This also includes a very nice chapter written by Rob about this ecosystem services models that he presented here today. So you can read this again also in this book. And of course, I would like to recommend you to check this SEA AR revision documents that you can download from this link, and also provide your comments. A lot of ideas we were presenting today are also included in this one, especially the conceptual ideas about ecosystem service supply and use are really worth to read and get some ideas what the current state of debate in this global group is. To conclude, all these things we presented here are indeed very, very complex. But the good news is, or the good thing is, that there's very broad experience and a lot of methods and data are available, founded on decades of scientific development and experience from landscape ecology, many other scientific disciplines that are involved here. And more recently, a lot of tools have been developed for biophysical modeling and also integrated assessments that can be harnessed for ecosystem accounting to quantify supply and use of many different ecosystem services. And this spatial modeling and also mapping of ecosystem services helps us to reveal supply and use patterns. And I think they are very useful addition to this commonly used supply and use tables that are commonly used in accounting. Many results are used in supply tables, but I think if we really put this in a spatial way and in a map based on modeling data, this is quite useful to really see clearly where which service is supply and where it is used and where there are mismatches. And of course, if you think about spatial decision-making and planning, maps are mandatory, otherwise you will not get too far for this spatial planning. So I think these tasks are very important we should never forget that this is about conservation and sustainable use of natural resources. So I think it's really worth all the efforts, and we should be very keen on training for the experts and improve the methods and apply them and learn for each other and do this knowledge sharing and capacity building also in the future. But I really think a lot of knowledge is there, which has to be used and integrated. And with this, I would like to finish my last talk today, and I'm looking forward for all the questions. And yeah, thanks a lot.
Many thanks to you, Benjamin and Rob, for these very, very interesting presentations. So following the schedule, the program of today, I'll give a very, very brief synthesis of the discussions. I tried to make notes while you were speaking. I think there was a lot of material that was presented. I'll try to be brief. And then we have hopefully half an hour left for, 20 minutes left for questions and answers. I think one thing that really emerged from both presentations was that modeling ecosystem services requires a spatial approach, because of the spatial character both of the supply and the use of and the demand of ecosystem services. I think it's also very important to come back to the three concepts that were mentioned in the presentations. That is supply, there's use, and there's demand. Three different things. And in the SIA ecosystem accounting thinking, supply equals use. And actually, supply of an ecosystem is used by a farmer to produce crops, for example. But at the same time, as Benjamin was pointing out, it's very important to keep in mind that supply, use, and demand may be generated or maybe located at different places, different areas. So especially for regulating services, for example, a forest may supply an ecosystem service, air filtration, but the use of that service is actually in a village nearby the forest where the air is cleaner and people are exposed to lower levels of air pollution. So these spatial relationships, as were brought forward in the presentations, they're very important. Of course, the focus of the SIA is on supply and use, but for many other economic analysis, demand is also very important. And demand, of course, can be higher than supply and use. In that case, there would be unmet demand. What was also really interesting, I thought, was the very nice overview of models and modeling platforms. And Rob, you mentioned Estimap and Invest in particular as two of the most used models. In addition, you said there was Mimes and Arias. Maybe one very small detail to add is that Arias is currently being converted or being expanded with a module that uses the SIA terminology. So you're able to directly kind of have SIA conform outputs from the Arias model. I think that's quite nice. At the same time, I think it's also clear from your presentations, and it's also my own feeling, that these modeling platforms such as Arias or Invest are not panaceas, right? It's not a fixed kind of a solution that would fit all contexts for ecosystem accounting. I think especially when you are in a data poor context and you're starting with ecosystem accounting, you would want to try these models. But over time, if you are increasing the accuracy of ecosystem services models, probably you want to develop models that are fine-tuned to the data that you have in your country, to the specific economic, social, environmental context of your country. And that means that you have probably a need for more sophisticated models compared to the kind of the global catch-all models that are in Arias or SIA or Invest. Then I think, Benjamin, you very nicely mentioned the challenges, and you also gave some solutions already for some of these challenges. It is quite clear, I think, that there's many ecosystem services and models around. So it can perhaps be a bit overwhelming when you want to start or continue ecosystem services modeling. But again, I'm fully with Benjamin in the sense that I'm also optimistic and positive about it. Actually, there's a lot of material to learn from when you're developing ecosystem service models, including the tools that were presented today in the openness tool and the MAS tool. Of course, there's also the scientific literature, and there are examples from other countries that have started or engaged in ecosystem accounting. And maybe it's good to mention in that context that the MAIA portal is also having a repository of ecosystem accounting studies and ecosystem accounting reports that have been published, including for the UK and the Netherlands, and we will build upon that of course, as MAIA is progressing, so you can find examples of ecosystem accounts where you also find details of models that were used to compile these accounts on the MAIA portal website. I think that's my short synthesis. So again, thanks very much, Rob and Benjamin, for these excellent presentations. Now I'd like to open the floor for questions again. We have a little bit less than half an hour, so we don't necessarily need to use the time, of course, depending on how many questions there are. So let me see if there's some raised hands. Ikramena, you raised your hand again. Ikramena from Bulgaria, please. The floor is yours again.
Oh, actually, I think that as you are giving me the floor, a question to both panelists. When we talk of single service models, there is always the challenge of forgetting about trade-offs or letting some powerful other groups take over the social discussion in a way. And a huge challenge in my view is actually to shift the social thinking towards not modeling a single service, but service bundles. In respect, it will be interesting to get your ideas on how to do this transition. It's not just a technical one. There are a lot of tools, but it's sort of change in the thinking.
Would you like to reflect on that, Rob or Benjamin? I think we agree probably, but maybe you have more to add.
I think it's a nice recommendation. I mean, to look more at ecosystem services, bundles and trade-offs. So we need these integrated models that can consider several services and also to include the social values. This is a recommendation, but as we've shown, I think this is very complex and there's no solution yet, but it's worth to work towards this, I would say.
Yeah, I think so. Yeah, no, I totally agree. I think something Benjamin said in his is that you're aiming towards the best available knowledge that you have on the situation that you can get within the context you're in. And yeah, when you've got these, or anything that's about the environment is interlinked, complex, messy, and so you're looking towards getting the best available information you can and a clear understanding of how you got there. And so with bundles versus it's about whether you lose anything out by focusing on bundles versus focusing on individual services. I'm just being aware of what that is. But I agree. I think it would make life a lot easier to deal with bundles. But again, I'm not sure the tools are necessarily there to do the whole suite of ecosystem services in the way that you'd like yet.
Wonderful. Thank you for that. The next question is from Fabio Delle Grazie. Fabio, could you please also name the institute you're working with?
Oh, hi there. Hi, everyone. Can you hear me well?
Yes, we can.
Super. Thanks for all the interesting presentations. It's really life-safe because I'm actually studying some ecosystem services from Ireland in groundwater-dependent wetlands, which is a quite complicated setting. So I need this kind of detail. It's very interesting. I was wondering, where do you see the implementation of the ecosystem service concept going as related, for example, to planning? If you see more integration in like getting more uniform methods of calculation, and for example, last thing, I am studying very small areas, so I guess you see more implementing small tailor-made models better than using like the more popular ones, which I'm kind of doing now because I have to pretty much adapt it a lot to my situation. Thank you.
Okay, yeah, so again, there's a difference in this in terms of disciplinary background here, because I come from a work with these very case study oriented things. So I would agree entirely that you want to be customizing towards something that actually deals with your local case as best you can. You start with something like Invest and you realize quickly that it doesn't actually do necessarily what your case study wants to do. So yes, but then there is the issue of scaling up, which is something I'll leave Benjamin to talk about, because for me it's about dealing with an individual case study location rather than the accounting at a broader scale.
Mm-hmm. Yes. Okay, yeah, that answers it.
And you said you work in Ireland.
Yes.
There's a very, I don't know if you're aware about, but there's a very detailed MAIA report from Ireland.
Okay, yeah, I'll look into it. I think I saw something, but yeah, I better.
Yeah. You can send me an email, I can send it to you. They did a very great job, nice maps, and a lot of very detailed stuff is available from Ireland there. Yeah.
Super, thanks, I will. Yep.
And in general, the other question, I mean, where do we go? Where I would like to go would really to have a kind of checklist for different ecosystem services on different scales and ecosystem types, and then really be aware, okay, what do we really need? It's not to become more and more complicated, more and more detailed. Some services may be quite logical or, yeah, not trivial, but easy to quantify and to model, and others are more complicated also depending on your case study. And if you can say, okay, if we want, this is what we do with this kind of decision trees, that we really can say, okay, what's the purpose of your study? Do we really need the highest detail, or is it enough to have an overview based on land cover data? What's your setting? So you don't always need the most complicated approach to receive useful results. But sometimes if it's really for planning on a local scale and where you have a high responsibility, then your data need to be very robust, of course.
Yeah.
Yeah, and I think on top of that, I've just thought of this on, in terms of this checklist, it would also be useful to have a transparency checklist. So in terms of the errors that are made in these kind of studies, so that you know where your assumptions are on a range, across a range of issues. Because that's the thing that you really need to flag. So you won't be able to have a modeling approach that doesn't have some kind of dodgy assumption somewhere. But if at least you can be transparent about how much you can understand different aspects of it by having flagged those and made them clear, then you know, you can work to improve them when you get a better model or whatever. But at least you've been as transparent and honest and, as you say, robust about it as possible.
Yes. I'll keep in mind that, especially for my PhD defense.
My feeling is, if I may add to this discussion, that we should probably invest a little bit more efforts in comparing models and models with working at different resolutions, models using different data sets, models using different algorithms. And I remember from work we did in the past, and which has not been published, unfortunately, we looked in Norway at carbon sequestration. So that's a service that's relatively well understood. And there we used two different models. And for one of the models, we used two different sets of assumptions. And then the difference, the spread that we had in these three model results was a factor 2. So of course that's still quite high. And but I don't think that is exceptional to have that spread in the results of a modeling outcomes. And I've got the feeling that we do need to do a little bit more effort as an ecosystem services modeling community to better understand the model outcomes as a function of our model setup and our input data and our assumptions, and also to cross-compare models and model outputs. I'm not sure, would you see that the same way, or do you have perhaps more updated information than I have on this topic?
So no, I'd agree with that entirely. The question is, are you trying to get a standardized method so that all of the methods approach and head in the same direction, or are you recognizing that actually different thought processes are represented in models, and so actually by looking at models using two different approaches, you can you get different understandings of how the system worked. We did a recent comparison between the ClimSave IAP and Image Globio, which were two assessment models with different thought processes behind them, both doing the same kind of ecosystem service models of a European scale. And it wasn't, you know, their results were very different for scenarios in terms of the directions of trends and all sorts of different factors, because their underlying logics were different. So the ClimSave one dealt with trade entirely differently to the Image Globio one, and that made a huge difference in terms of the supply of ecosystem services. Does that mean that one's wrong and the other's right? No, it means that if you're trying to understand a scenario, you need to take these things into consideration, and that that different approaches come up with different results. And you can still use that to move forward, but it requires some intelligence to do it rather than actually getting a number that just gives you the right answer. So yes, I totally agree, you need to compare approaches, and actually that process is a learning process in itself. But it doesn't help particularly if you want to have a set answer, because again, environment is so complicated. Set answers challenging to get. Understanding process more important.
I fully agree, and there are studies going on to compare different data, input data, and different modeling approaches, like modeling the same service in the same ecosystem, and see what's the outcome. But we have to be aware for some services, model is the only approach to quantify it and to account for it. Like especially regulating ecosystem services, of course, you can do some direct measurements, but some processes take place on large scales and you will not be able to measure water flows, for instance, in such a detail as you can do with the model. So this is really the only approach. That's why they have to be robust and you have to be sure about uncertainties and communicate them, but otherwise you will not be able to quantify them. So this is, we are relying on models for many services, I think.
Yeah, and that was again the point on uncertainty, because there's many ways of quantifying uncertainty, but there's loads of different types of uncertainty, and quantifying the uncertainty that comes from using this model or that model can't be done with an R-squared. So there's a whole range of ways of thinking about uncertainty and thinking about it holistically across from kind of to what extent does this represent the real world thing it's supposed to represent? It's actually quite a big question and involves thinking all the way through from data through to the modeling, through to the scenarios, through to whatever. So always fun.
Thank you for these responses, Rob and Benjamin. Thanks. So I see there's another question from Sheikh Abdel Kader Baba. I'm sorry if I don't pronounce your name entirely properly. Please state also your institute.
You pronounce it well. My name, I'm working for TMG Research. Hello, can you hear me?
Yes, we can. Please continue. Thank you.
Okay. I'm done with a question, but I'm still hesitating because I'm not so sure whether it was really relevant to this forum. Benjamin project, in his presentation, there were like a graph where you have like service provision area. Then you have like farmers, you have like agro-business, and it goes to the service to another, I think it was like service provision unit or area again. I'd not. It seems like I'm missing something. So my question here it was really like about the decision. I clearly understood that if we want to quantify, to value, or to model ecosystem services, key questions imply, for example, what do you want to quantify and value? At what scale, and probably for what? And reading all the difficulties, scientists have in enforcing decision making with all what we produce in terms of finding on the result, I was stunned by a question: at what scale do we really need to put effort when, for example, considering like the scale of no, not the scale. I'm sorry. Normally I speak French. My English is not so good, so sorry if I'm spending your time. What I'm trying to say is, if I take the practical example of like a farm, the farm may produce some services valued by the farmer, but it can also benefit some agro businesses, and at the end it will jump in a kind of supermarket where you have yogurt or whatever. So for decision making, where do we start the quantification and valuation? Is it at the supermarket, or it has to be, for example, at the farmer and business level, that we have the better chance to sustain what is going on the farm? Because at the end, from the old ecosystem quantification, valuation, and all the models we are producing, the aim is to sustain the landscape, the aim is to sustain the ecosystems. But if we have like a kind of multi-level decision makers, everyone perceiving some benefits, and at the same time, no one is responsible for sustainability, how do we sustain these ecosystems we want to sustain? That's why I'm still asking, at what level do we want to put more effort? Is it like at the farm level, agro-business in this interrelation, or business? Sorry for taking your time. It would have been easier for me to do it in French.
Jacob, it's perfectly fine. Your question is clear, and I think it's a very good question as well. So thank you very much for that. So Rob Benjamin, would you like to have a go? I also could respond to that, but please.
Maybe I can start. I was putting this question on the table. I mean, you quite well summarized what I was presenting as a problem, that we have this complex supply-use change in agriculture. And of course, from an ecosystem service perspective, it makes sense to say that the supply is from the field. So the area where the last contribution from the ecosystem takes place, that's where the ecosystem service is supplied. Then looking at use, it gets more complicated. And I just read in a comment from Patrick that in the Netherlands, the agriculture sector is seen as the users of crop production services, which sounds interesting. But in the end, the user is, for me, the final consumer who is eating the products from agriculture. This is quite relevant. But in between, there are so many people involved, and some of them may change the good and the service. They may refine it or pack it or do some other things. And of course, all these people involved, they want to have their share of the profit. And then if you would add up the value, in the end, you have a price you pay as a consumer. But of course, the wholesaler, the transport company, the food refiner, all they want to have their benefit and their price of it. Does this mean, and we don't want to discuss evaluation here, but does it mean that the product becomes more valuable since it goes from the field to the final user? This is, of course, also discussed in agriculture policy for the farmers, how much they receive. So this is very tricky, I think. But from a modeling and mapping point of view, of course, we can be very pragmatic and say, okay, the supply is on the field, the user is the final beneficiary. And all the things in between we would not consider in case we have all the data. And that's what I said in the end, if you don't have the data, you have to go to the most appropriate level where you have data, which usually are the trading companies. And even this is difficult. Sometimes you only have regional or national statistics for trade products. So this may limit your assessment. But the question, we have to put more effort. This really depends on what you want to know in the end. If it's for awareness raising, it may be easy just to show some maps and say, okay, this is supply, this is what we need. They are mismatched. If you really want to change agriculture policy, of course, you need some more detailed and robust information. So it really depends what you want to know in the end, where it's worth to put more efforts.
Benjamin, if I may comment on that, because the second part of my comment was on that the whole transfer of agricultural crop products towards the end user, which is the consumer always, that is already captured in the structure of national accounts. And because we have information on that in terms of just classic input-output tables, you can just easily compute how these products end up with both domestic and foreign end users. So there is no need to be concerned with that in the exploration of ecosystem services. That can be perfectly handled by the national accounts. And because, at least in the SIA world, the ecosystem accounts are designed to match the national accounts. And if you combine the two accounts, then you already have the complete picture.
Thanks for this addition. Maybe I'm too spatial because I see this national accounts as tables. You have numbers and tables, but do you really know where these final consumers are located? I mean, you don't know where the persons are. Where do they eat the things? Where do you put this? If you have a sandwich in your office in the city, or do you have it at home? I mean, do we need to know this information is another point, but I think these tables are very good. You have very good numbers, but when we talk about spatial modeling, biophysical modeling, we can look at these numbers.
Yeah, but especially in the maybe worldwide it's different, but at least I've seen some pictures from the Netherlands where they show the whole chain, the agricultural food chain, and then you have thousands of farmers with hundreds of products and dozens of food producing factories. And then there is only, I think, five organizations who do all the trading. And then it's sent to tens of supermarkets and other chains with, again, thousands of different shops and millions of consumers. But the whole chain has a shape of first funneling into this very small set of wholesale traders before diverging towards the consumers. So this spatial component, especially for food, is largely lost. I think for most, and not of course not for all products, but for most of it is completely lost there.
So I think this was a very good question, and it really raises an important topic in the context of accounting, because indeed, as Patrick said, in the SIA accounting framework, it is established that supply equals use, and therefore supply of that ecosystem service supporting agriculture is used by the farmer. But at the same time, I have to fully agree with Benjamin that if you want to really fully understand the benefits of your ecosystem service as they kind of multiply across the value chain, you would need to look at that end consumer of your yogurt or your marmalade. And as Patrick was saying, indeed, that element of these next steps in the supply chain, the value chain, they are covered in principle in the national accounts. So it is possible to make that link. And so that and not in a spatial way, indeed, but at least in a monetary way, we would be able to estimate perhaps the value added generated in different sectors, retail, transport of your food product. So that information should be there. Having said that, I must also admit that we haven't really, at least I haven't seen any ecosystem accounts where that analysis was actually done to follow through the whole value chain. Okay, now what is the value added of that ecosystem service in the next steps of the value chain? So I think actually that is a really important and interesting outcome of a discussion. That is one of the topics that we could consider for further work also. And see if we can analyze that. And I think it's also relevant for another reason, and that is that in the Netherlands and in the UK, it was found that the value, the monetary value of the ecosystem services related to supporting agriculture was really quite low. Compared to other services or compared to our GDP. And partly that's because farming is a really knowledge-intensive and capital-intensive business. But in a way, of course, it doesn't do justice to the value of food products later on in the value chain. And in my mind, it's something that we should be looking into in the coming years to better understand how that works.
We do have an Eurostat grant, Lars, in order to look into this, to look at the whole product chain of agricultural products, and then try to link the physical flow with the monetary flow, added value, and also the nutrient footprints, especially nitrogen.
Oh, really? Oh, that is wonderful news, Patrick. Okay, great. Oh, that's good. Oh,
they'll be mostly carried out in 2022, I'm afraid, but.
Okay. Yeah. Well, this is an ongoing process, though. But to finish perhaps the discussion, I think it's good to update you on the status of the SIA ecosystem accounting framework. So the UNSD, UN Statistics Division, is aiming to present the revised, so following the global consultation of global review, the revised SIA framework to the UN SIA, the Statistical Commission on Environmental Economic Accounting, in June of 2021. And then hopefully we will be able to have a much more standardized and concrete and agreed upon framework for ecosystem accounting, where all these definitions and concepts are defined even more precisely and in a way that has involved a much broader participation compared to the previous SIA framework. So I would say that there is important progress being made in that whole process towards standardization of all the concepts and definitions. I think there are no further questions. So from my side, that would be my concluding words. Rob, Benjamin, is there anything you'd like to add at this point in time before we finish off the session?
There are some questions in the chat, I think. I don't know if we should refer to the questions in the chat still, or otherwise, I think it was a very good discussion.
There's a question of will the presentations be shared with us? Yes, the presentation and the recording will be on the MAIA portal. So you can always look back things. I think is there any other pertinent question? Because otherwise I think we're going to close off. Rob, any last word from you?
Yeah, nothing from my end. All
right, then I would like to thank everybody very much, especially the speakers, of course. Rob and Benjamin, you've done a wonderful job, I think, in laying out such a complex topic here. And many thanks also to all the participants who joined and for the interesting discussions that we had. And well, I wish you all the best in this new year. Hopefully COVID will be able to start controlling the whole situation and we can go back to normal at some stage during this year. I certainly hope so myself with two